Hello and welcome to Module 4, the Linux overview. So we're going over a new operating system, well, not a new operating system, the other operating system that is the most widely used in networks and uh, the cybersecurity world. So Linux is a new operating system, and we will be covering these different topics. Um, We will go over 15 minutes, so I don't know how long this is going to be, the video, but what I'd like you to do is take your time while you're listening and taking notes. You don't have to finish this whole thing in one setting, so maybe take it over several days. This way you'll return more. Don't forget that you have to take the notes that I asked you to and submit them as proof that you have viewed the lecture. Okay, so let's get started. Let's talk about the Linux basics. The Linux operating system, which was created in 1991, it's really uh, part of the Unix operating system. It is an open source, which means anybody can be using it. It's free, it's fast, reliable. It uses very small amount of memory and very small amount of CPU power. So that's why people love to use it because it's free and it almost runs on any machine and it's very, very stable. All right, so take the first two bullet points, um, write those down, and write these four bullet points. You don't have to write down the definitions of each one of them. Why would you want to use Linux in your on your device or in your networks? Well, like I said earlier, because it's an open source. Linux is very, very powerful. It's been around for many, many, many years, and it has been enhanced by many experts, and it's free, right? The user will have more control over the operating system, make changes to the configuration or whatever they need to do. And also, it's a lot more stable than many of the other network operating system. So it works very, very well in the network operation control. The TCP/IP was based on a Unix, which is a subset of the Linux operating system. In the Security Operating Center, the SOC, you will use the Onion Security Suite, which is also an open source based on Linux. And within it, there is the Squill cybersecurity console, which is used to analyze data. We will use this down the road. So this is an example of where Linux can be used. It's very, very flexible. All right. Please take the following screenshots. So these are several tables that what the SOC, the Security Operations Center, needs. They need to have a capture software that captures the data, a sniffer, in other words, like Wireshark, to analyze the data that's floating, traversing the network. They need to have some malware analysis tools to find out, to observe all the malwares and they're being executed, to find out, like any Trojan horses or viruses or anything like that. They need to have an IDS system that can actually detect if there's an intrusion, if somebody actually broke into our network or our devices. Snort is a typical software that will allow us, is a typical free open source IDS system that we will use. Take a picture of this as well. There are firewalls. Firewalls is like a security guard that either permits or denies packets from going in and out of the network. You need to have log managers in the SOC as well. Log managers, they're going to keep track of all the events that are occurring in your network or on your devices. Then you need the SIEM that we talked about last week, or maybe a couple of weeks ago. The SIEM is the analyzes all the alerts, all the data that is being captured, and to find out, hopefully, that we can find out a solution. And you need some sort of a ticketing system. So when there is a problem, a user or a host has a problem, they need to call in and a ticket will be generated. And the ticket is typically, we call it, it's open as long as the solution is not um, been completed. So once you have solved the problem, then you can close the ticket and send the user an analysis of, or a complete analysis of what actually happened and how we solved the problem and what not to do next and all of those other things. And the ticketing system is also important. It keeps track of all the work that you have done. Documentation is extremely important within the SOC. All right, so here's also a typical Linux operating system suite, Kali Linux. Kali Linux is mostly used by the ethical hackers to penetration test the network or devices. Pen testing, meaning you are an ethical hacker, you're trying to do what a black hat hacker would do. They will use exploit kits to break into your networks. So what Kali Linux has aggregated all of these different types of exploit kits and utilities that you can use as an ethical hacker to try to find out where there's vulnerabilities in your network. Right? This course that we're doing right now, the CyberOps course, is not an ethical hacking course. It's it's the other on the other side. That's what we're doing here is we're trying to do the defense part of it. We find out what's wrong and we build the defense. We build the firewall. We're trying to find out exactly what went wrong. We're not doing pen testing. We're trying to find out where we've been attacked and who attacked us and what they tried to retrieve. Pen testing is the other guys on the other end when they try to break into your network. So Kali Linux, you'll find that being used extensively in an ethical hacking course. All right, let's get into the actual command line, or sometimes we call it shell, of the Linux operating system. So in Linux, the user communicates with the operating system either using the command line or a GUI. Command line, a lot of people love to use the command line because it's easier to use and you have more control. So in the latest versions of the Linux operating system, they usually comes with the GUI, the graphical user interface. So just for terminology purposes, please write down this note on the bottom. So this way you are familiar with this, because if you listen to videos on YouTube or have other lectures, you may hear the word shell, console, console window, CLI terminal. They all mean the same way. Same thing, really. Here's a typical Linux shell. All right, so it's really like the command line. This is the prompt itself. The $sign is where, in Windows you have the greater than sign, and this is where you type your commands. All right, take a picture of these. These are some of the commands that you should be familiar with within Linux. So for example, MV is when you want to move or rename a file. PWD, PWD will display, for example, the current directory, the folder that you are in. SU is also sometimes being used as super user. So SUDO, super user do, we will use oftentimes to give you the ability, the supervisory rights to execute a command. All right, type these commands or do. Here's the sudo that I was talking about. Then you have the grep, the ifconfig. This is to something similar to ipconfig to find out your IP configuration. So in Linux, it's if. That's the only difference. apt-get is to install a software. The software, we call them usually packages. In Linux, instead of calling it a program, we call it a package. iwconfig is if you want to find out the configuration of a wireless network card. Shutdown is, of course, when you want to shut down or restart a specific app. CAD is like the edit to allow you to list and edit a file. Okay, man is for manual. We'll play around with these in lab. all of these different types of commands, but I want you to at least take a snapshot of all of these different commands and get familiar with them. Open up a Linux shell and practice them if you have not done so. All right, so let's talk about the text files. iTable. The nano command is like when you want to edit a file into, you want to create a small text file, because everything in the Linux operating system is really treated as file. Memory, CPU, you name it. And so when the Linux boots up, it goes to that specific configuration file, reads the configurations, and sets up the device according to whatever the configuration you wrote. So you would use the word nano space, whatever the name of the file, and then an editor will come up. And then you can type and you can do this in the caret, control, X, for example, exit. That will exit the nano, the editor, and then will allow you to save it. And we'll see that. Again, we'll practice some of this and when we go through this, our labs. So text files are very, very important in here. So please write the first bullet point, the important text files in Linux. Everything is treated as a file. This includes the memory, the disk, the monitor, the directories, and also write the second bullet point. Configuration files are all text files as well. So here's an example. The administrator executes sudo nano / etc. hosts. What this does is going to saying super user do. I want to execute the following file, which is located in the etc. / host. I want to edit it with using supervisory rights. Super user do. That's what sudo means. Okay? All right. So this is also, here's a typical shell. This is what you did when you after executed that command. This is what you would get, and you would type in all the commands that you want. You would hit Control X for exit, and they will ask you to save the file. The file will be saved as hosts, and you can get out. So nano, you can use that. The nano commands. Again, we'll play around with this when this lab comes up. You'll be able to have a good experience with it, hopefully. All right, now let's talk about the Linux servers and clients. This is really just a common server. A server is just like any other server, is a computer that's running a specific software that will give out services to hosts, workstations, clients, sometimes we call them. So a client, such as a computer, or even a phone, or a PC, would go and sends in requests information, maybe a web page, maybe an email, maybe whatever they want from the server, and the server will service it. Okay? So servers are computers with software installed that enable them to provide services to clients. So what's the difference between a client and a server? It's really the software that's running on it that makes it a server. And you can set rights and privileges, authentications for specific users, what they can and cannot do when they log in, and so on. So the server can control a lot of things that you could do in a network. All right, here are and the different types of services or applications that a user can and cannot do is typically assigned a number. So all apps are typically assigned a common port number, we call them. These are port numbers. So port numbers indicate what type of service that the server is running. So for example, if you want to secure shell, which means remotely access a device, you are going to use port 22. So when you search and scan a specific network and you see that port 22 is open, that means you know that somebody is using is secure shelling into the network. If port 25 is open, for example, that you know that being email is being sent and being sent to an SMTP server, right? So port numbers indicate what service has been opened on the server and open to retrieve data. Now, why do you need to know that? Because hackers may use those open ports to send malicious data to your computer. All right. You should remember these port numbers. So please take a snapshot of the first two slides, this slide and this slide. We do cover these in other classes, but you should be familiar with them. Again, port 80, for example, is for web pages. So you can send information through port 80 if you know. Remember, port 80 is all the data that's being transferred through the HTTP is in clear text. You definitely want to use HTTPS. You never want this port to be open. You want 443 port to always being used when you are transferring web pages, right? All right, so clients are the ones that requests data from a computer or from a server. But if the port is closed, you won't be able to get, if you're trying to, let's say, Telnet. So you need to have port 23 open. And if it's not open, and if it's closed by the firewall closed it. Because when your request comes in, the firewall looks at port 23 and says, hey, wait a second, you're trying to Telnet, and we shut it down. So you won't be able to Telnet, for example, right? All right. So now let's go to some basic server administration. Again, like I said earlier, all services, just like hardware, are managed using configuration files. So that's very important. So please write this down. Typically, you will you'll use the cat, just like Nano, to change the configuration of a specific file. So cat, and this is the path where the file nginx.configuration is located. So that will open up. You can edit the file, right? And then you can save it later on. And then the Linux operating system, whenever that file for NGIX is booted up, the application, they will look at the configuration, what changes you have made, and it will change the behavior of that application, however you want it to change. So common, please write the first, at least this bullet point, the first two bullet points. So common options in the configuration files are port numbers, location of the hosts, and so on. All right, so this is also a typical NTP, the timing protocol. You want to change the configuration in that too. You could do that as well. Here is the snort. If you want to change some of the values of the configuration file of the snort. So you use the cat. And typically, if you write the word option, equal to 1 means activate, 0 means deactivate, just to let you know. Hardening your devices. What does hardening your devices means? It means you want to get rid of all unnecessary services that are running, shut down all services, or disable utilities that are not being used. Okay, that's very, very important. And update all the updates that are needed, the patches that are required. Make sure your operating system is up to date with the latest and the greatest updates. All right, so please write the first two bullet points down. So implementing proven methods of securing the device and protecting the administrative access. You always want to use SSH instead of Telnet, for example. You always want to use HTTPS instead of HTTP to access web pages and so on. So, and you can set requirements within the server to force users to use SSH or HTTPS. Please write this down. So these are the basic best practices for hardening your device. So take all of these notes down. Ensure the physical security of the device. Make sure no one has physical access to your computers or especially your network devices, routers, servers, switches, and so on. Very, very important. So if you lock the room where the network room, there's going to be a lot of heat generated. So make sure you have HVAC system and a monitoring system to monitor the network room. Make sure you have enough ventilations in there. Minimize installed packages. You don't want to do a lot of packages getting installed, and that will just maybe overwhelm the network. You want to only install what you need, because you don't want to hog the CPU and the memory. Disable all unused services. So if anything that is not being used, there's a lot of the operating system will have some excuse me, unused commands or services that are being executed by default. Hackers know that, and they may use these unused services to gain access. So if you're not going to use these services, shut them down. You can shut all the services down and enable only the ones that you need. There are commands or utilities that will allow you to do that. Anytime you want to access your device, use SSH, because all your data will be encrypted from where you are and where the server is. So when you are remotely accessing any device, you want to use SSH over Telnet. Okay? Disable the root account. This is like the supervisor account when you are accessing SSH, because then you have control over everything on the network. Keep the system updated, of course. Disable the USB detection. You don't want anybody to be able to use the USB connected to your device, because they can easily transfer viruses and malware. And strong passwords, you want to enforce that. And strong password means you want to use maybe a phrase instead of a word, at least 10 characters, I recommend. Capital letters, lowercase letters, and some numbers in there, and even some symbols. And that will makes it very, very difficult for somebody to crack your password. Passwords are very, very important. They are the number one thing that a hacker will try to gain access to before they break into the network. Because if they have their password, they don't have to do anything else. You make their job much, much easier to break into your network. You force periodic password changes, and the reason you want to do that, even if your password's strong, given it enough time, they'll figure it out. But if you are, let's say, every 6 months or so, you change your password, then you interrupt this use. So it makes it almost even harder. Keep user from reusing their old password. So there's a way you can set up even in the Windows system that you can't use the last 7 or 8 password that you have used. You have to make changes to it, because there are exploit kits that will allow you to use old password by just adding a number or something like that to make it easier for you to remember. That's fine, but you cannot use the same old password. Use one password and recycle it over time. That's not recommended. All right. To monitor service logs. So please write these down. In Linux, you need to know how to access the application log, the event log, the service log, and the system log. Remember, logs they keep track of everything that happens on the system. For example, in the system, you go in there. If it's a specific event that occurred, you added a new applications or you installed a new hardware, you may see it in the event. And a specific application did something. So you go into the application log. You need to have access to them. A lot of the software that are designed that will analyze your a specific attack, they may need access to an application log to analyze the logs to see if there is an actual vulnerability, or to actually see if what happened is a problem or not. So you need to know at least the location of them. And sometimes you may have to read them yourself. and trying to analyze to see if you could do something to mitigate the problem. All right. Take a picture of these. These are where the location of some of the most popular log files that are located. There is the messages, there's the authentication log. Every time you authenticate, all that information is logged in here. The secured, this is for the Red Hat and the CentOS operating system that keeps track of all the logins of the sudo, the super user. The boot log. Also take a picture of this. This is for the kernel messages. This is also another log file for the kernel. This is the cron, which is a service that is used to schedule automated tasks in Linux. And this is the for the SQL file, if you have an SQL operating system, a database, that is. All right, here are some examples of the, for example, the message log. You may not need to, you should be familiar at how to analyze some of these lines, but I don't think they're going to require you to do all of this. Let's take a look at the file system. This is something similar. What is the file system? Similar to the Windows operating system. That's what I wanted to say. The file system is the guy that takes the data and is responsible for saving the data on your hard drive. So it is the one that is responsible for retrieving the data and placing it. If anything happens with the file system, then you will not be able to retrieve your data. So there are many different kinds of file systems that are available. Some of them, you may choose one for flexibility, you may choose one for speed. One gives you more efficiency in using your hard drive, and so on. So it all really depends. You decide on which type of file system that you want to use. There is extension 2, there's extension 3, extension 4 as well. So this is typically the default file system that is set when you install a Linux operating system, extension 2. This is really for flash hard drive. It's typically what is being used, and it can pretty much do everything that you really need. So extension 2 is really great. You can use extension 3, which is really, it keeps a log book like a backup. So this is something that you may want to consider of all the changes that are made. It keeps track of it, and it can actually handle up to 32 terabyte. Take a picture of this. Extension 4 is created, the latest and the greatest. This is really an enhancement to extension 3. It's being used, don't get me wrong, but you really don't need it as much as probably extension 3 is something that is good to have instead of extension 2 file system, and it's more stable. There is the NFS. There is the NFS, which is the network-based file system. This is typically for network. So from the user standpoint, you really can't tell if you're using a specific extension 4 or an NFS. So this is to allow you to save files not only on your physical hard drive, but you can save the file on a server. Okay, so take a picture of that. The CDF is the way you can save file on a CD-ROM, right? Disk media or DVDs. The swap file is allow you to use, if you don't have enough memory and you want to, which is really a shame, because that's the cheapest way of really giving your system a boost is to really increase your memory. But anyway, the swap file is, if you don't have enough memory, the operating system may use the hard drive as a RAM, but it will slow down the execution of the file. So if you have an application that requires 4 gigs of RAM to boot up, to start, and you only have 3 gigs. So 1 gig will be placed on your hard drive in a swap file. And whenever you need that 1 gig that's on the hard drive, you swap with whatever is in the memory. And during that swapping, your CPU is not executing anything because the CPU only executes data that's in the RAM. And if you don't have enough RAM, it has to wait for it to swap with the hard drive because it's using the hard drive as memory. And so accessing the data from the hard drive is much slower than accessing the data in the RAM. So to minimize the swap files, just purchase more memory. Have 32, 64 gigs of RAM. Your system is going to love you, and it will run much, much quicker. Then you have the HFS. This is more for Apple, and the APFS as well. The master boot record, again, take a picture of this. The master boot record is an area on your hard drive is where the file system is located. MBR is very, very important. He's the one that knows where the file system is located, boot files that are required to boot up the operating system. So he's the one that keeps track of everything, at least till after the system has been booted. His job. If the master boot record that keeps track of all the important files, such as the file system and the core operating system, if that guy is corrupted in any way, again, you will lose access to all the data that is on the hard drive. So it is very, very important that the MBR is protected. And typically Linux and even Windows operating system will make sure that no one has access to the first sector of the hard drive. So it's read only. No one will be able to put viruses in there or anything like that. All right, so the file system in Linux, so this is a typical one. You can give permissions to a specific file. Read, write, and execute. Read means you can only see it. Write means you can make changes to it. Execute, if it's an executable file, you can run it. So this is what rights you have to a specific file. So for example, if you type ls list with -l and the space of the text file, so this is what it's saying. It's saying that minus means, if this is for the user, the one, well, you can read all of that. But you have 2 people that own this file, space.txt. You have the analyst and the staff. The analyst has read, write, and execute. The staff has read and write only, dash means nothing. And everybody else has read only. Okay? That's what this means. So take a picture of this. This will tell you on how the permissions for a specific file goes. All right? So for the user, read and write and execute. Minus means it's a file. If you see the word D in the very beginning, it indicates that it's a directory. So in our case, for space.txt, it was the dash, the minus, indicating that this is a file. So the first user, analyst, had the read, write, and execute. The group, called staff, had read, write, and I think read and write only. Yeah, read and write only. And everybody else had only read. Take a picture of this so you'll understand that the permission breakdown. And take a picture of this as well. And please read them so this way you'll have a better understanding of how file permissions work in a Linux operating system. Hard links is like a copy of a specific file. There's hard links and simple links. So please write this down. A hard link is another file that points to the same location of the original file. So if you make changes to the specific change, if you make changes to the original file, changes will be made to the other file as well. So if you type, for example, ln space.txt hard.txt, that will give you have another, like I'm making a copy of it, right? Both files will point to the same location of the file system. If you change one file, the other is changed as well. So please write this down, right? That's what a hard link is. The echo command will allow you to add some text into the text file, and then you'll see changes that happen into the space.hard.txt. The symbolic link is really the same thing as the hard link, or sometimes we call it a soft link, so please write this down. All you need to do is just put a minus S instead. If you put ln minus S, it becomes symbolic. Okay? The changes will still be the same. So it's really acting like the same thing as the hard link. So take a picture of this. So symbolic links can be linked to directories. Hard links, you can't link them to directories. So that's one main difference between them, right? Hard links are limited to a file system in which they are created. Symbolics, they can be in another file in a different file system. For example, if this was done in extension 2, it could be sent to extension 3. We can't do that here. Located hard links is difficult, but it's very easy to find out where soft links are. This is like similar to copying a file, right? So it's probably a good idea to always use soft links because they're a lot more flexible. The GUI operating system of the Linux is really based on the X window that allows you to use your mouse and little icons and things like that to execute. So here's a typical GUI operating system of the Linux versions, like the Kali 2, I think it showed up before. The Ubuntu is the most popular one. So again, if you're familiar with Windows, you should be able to manage with very small learning curve when you're trying to learn the GUI, the Linux GUI. All right, don't worry about that. This is just telling me the GUI operating system. The host itself, installing and running applications. This is important. This is a command that you need to know. Please write this down, the sudo apt-get update. So whenever you want to install an application on a Linux machine, we call that program or that software a package. So you need to get that package and install it. Use the apt-get, right? So the command shows you, apt-get update, and it will just update the latest and the greatest for the operating system. Okay, keeping the operating system to date, you may use the pack. Depending on your operating system, you may use pacman or you may use the apt install. I'm familiar with the apt. So please write these down anyway, just in case, depending on which type of operating system that you're using. But you need to use the commands to get the latest and the greatest updates for your operating system. All right, so you may want to upgrade your operating system by typing apt-get upgrade or update it or remove or install a specific application. So you're right, these commands are very, very important for us to use down the road. All right. Processes and forks. A process is just like within the Windows. A process is, please write that down. A process is a running instant of a computer program. So if there's a specific portion of the program that is running, we call that a process. Forking is making a copy of this, making a copy of a process. So having the copy of itself running at the same time, because sometimes you need to do that, make that copy, let it run, and in the original one, you want to make changes to it. You could do that within Linux, believe it or not, which is really nice. So forking allows you to do that. All right. So to allow you to some tables, there is the PS, which is going to list the process, all the processes that are running at the same time. Sometimes we use the word kill to kill a process. because let's say you're running a specific, sometimes there's a process in the networking process to allow you to communicate with other network devices. You need to have a process for the networking managers to be running. So you would write PS blah 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 and then let it run. And if you need to execute something else, you may need to kill that process. Stop it, in other words. You'll use the command kill. Okay? Please take these, take a picture of this. This is will allow the 3 commands that are used to manage the processes. Malwares, when you are running malwares on an operating system, again, like we said earlier, Linux malwares will include everything, including, just like on a Windows operating system, you'll have viruses, Trojan horses, worms, you name it. So you want to be able to mitigate against all of these different viruses. And one way is, for example, here you can telnet, here's an example, you can telnet through port 80. So you want to telnet to this device through port 80, you can do that. The attacker learned that, oh, I can go through port 80 because port 80 is open. So let me remotely access this device 209.165.200.224 through port 80. Okay, so that's why port 80 should be closed, for example. Rootkit. A rootkit is very, very difficult. Rootkit is, please write this down too, the first bullet point, is a type of malware that is designed to increase an unauthorized user privileges. A rootkit is placed on your hard drive, and as soon as it's placed on your hard drive, it will give itself more authority, more privileges than normally is allowed, and make copies of itself, and even erase itself. You can't even figure out where it's located. It's very, very, very difficult to detect. If you have a rootkit on your system, it's almost impossible to get rid of. And the only way to really solve the problem is to wipe out everything and start all over again. But you can use the command sudo /check rootkit, and it will go through and double check to see, it will do its best, try to figure out what if there is a rootkit installed on your system. The piping command will allow you, this is also, please write this down. You can take a picture of this. Usually is designed to, instead of typing a command and getting a whole list of unnecessary information that you may not need, you may use the piping command to pinpoint exactly to what you want. So you may use the ls and the grep file to, hone on exactly the information that is needed for you. That's what the piping is used. Okay, so in your book, please do, in your ebook, when we get there, please look at this video, and then we'll go through the application of rootkits on the piping command and all that good stuff, and actually installing some of the software. And so this is definitely a good 5-minute video to watch. Okay, so spend about 43 minutes or so. So please take all the notes that I asked you to do in a Microsoft Word. Please upload them, and I will see you in Module 5.